In this video, we'll finally show you our latest prototype, a self-supporting single-phase electric generator using patented magnetic technology, the Liberty Engine 5.0. Stay until the end to understand how this generator works. For this new prototype, we need two three-phase electric motors. We chose these two motors because they have the same characteristics. We'll use this motor later. These three-phase motors can operate at 220 or 380 volts with three-phase alternating current and a power of 1.5 kilowatts. We'll begin by completely disassembling this motor because we're going to transform it into a high-efficiency alternator. First, we'll remove the rear cover and the blades. Now we'll remove all the bolts holding the structure together. By tapping it lightly, we can extract the rotor along with the rear cover. We need to remove these two bearings. To do this, we'll place a bolt on the thread at one end of the shaft to avoid damaging it when using the bearing extractor. With this tool, it's very easy to extract any type of bearing. You'll find the link in the description. We repeat the process with the other bearing. On the lathe, we'll reduce the rotor's diameter by 1 millimeter. Then we place it on the indexing plate of the milling machine to make 12 equally spaced slots around the rotor. Each slot measures 19 millimeters wide and 4.5 millimeters deep. We lower the ends a little on the lathe again. And this is how the machining turned out. Here are 12 adhesive sheets made from a special alloy composed primarily of silver and aluminum, Argalium Alfa. We've discovered that our prototypes work just as well this way, but we've significantly reduced the manufacturing cost by not having to manufacture the entire rotor from this expensive and difficult to develop material. We'll place one sheet in each slot. This way, the entire rotor acquires the properties of Argalium Alfa. Here are the neodymium magnets that will glue into each of the rotor slots. With this magnetic pole tester, we'll identify the north and south faces of each magnet. We classify the magnets so we don't get confused when placing them on the rotor. We'll need to glue them with cyanoacrylate adhesive. Be careful with your eyes. These magnets are neodymium N52 and measure 40 for 19 for 4.5 millimeters. They are custom made to fit 2 magnets per slot. We place the north polarity magnets in alternating slots. We've already placed them. Now we'll move on to the south polarity magnets and place them in the remaining slots around the rotor. The process is the same, 2 magnets in each slot. Our rotor is now magnetized and boosted. Thanks to the Argalium sheets, we'll eliminate magnetic braking. We check that the polarity of each magnet is correct and continue with the manufacturing process. We'll cover the magnets with a layer of epoxy resin to give them more strength. To do this, we'll create an airtight container around the rotor. We glue a small sheet of polycarbonate. We place the shaft over the bearing so it can rotate freely in a vertical position. We seal it with clear silicone to prevent epoxy leaks. Now we'll cut this Coca-Cola can to create a cylindrical container. We'll use only this piece, which we'll also glue with silicone. It must be centered with respect to the rotor so that the epoxy properly covers all the magnets. We let it dry for 24 hours before filling it with epoxy resin. Once it's dry and perfectly glued, we prepare the resin mixture. Epoxy resin consists of two components. We add 150 grams of component A, or base, and 70 grams of component B, or catalyst. When they are mixed well, a chemical reaction called curing occurs, which turns the liquid mixture into a solid, rigid, and very resistant material. We carefully pour it into the prepared container and let it dry for 24 hours. The next day, the resin is hardened. We remove the container. We cut it without fear. Epoxy is very resistant. We're almost finished with the heart of our self-supporting generator. We're going to machine the surface on the lathe until its outer diameter is 89 millimeters. This will also ensure the rotor is perfectly balanced. Balancing is very important. It reduces vibrations and noise, increasing the efficiency of our Liberty Engine 5.0. Now we have the rotor balanced and the diameter required to fit inside the engine. We replace one of the bearings and insert the rotor into the housing. We must be very careful because the magnetic forces will force the rotor into the stator. We continue assembling the housing covers and reattach them with the bolts. If you're unfamiliar with previous versions of the Liberty Engine, we invite you to explore them using the links in the description. With these modifications, we have converted a three-phase motor into a high-efficiency alternator, capable of generating up to 20 kilovolts of power. By eliminating magnetic braking and eddy currents, we have also eliminated the heat generated when generating electrical energy. We reinsert the blades onto their shafts. Now we open the alternator's junction box. We remove these copper plates to check the location of each stator coil. To check this, we will use a digital multimeter. We set the selector to continuity. When we connect the two terminals, a beep sounds. We check where the coils are. A beep should sound between both ends of each one. Between these two ends is an internal coil. Between these two ends is the second coil, and between these two ends is the third coil. To make the generator as efficient as possible and output the maximum voltage, we connect the three coils in series. This way we obtain a single-phase current output. We connect this point to this one using a small copper strip, and this terminal to this one using another small strip. The two remaining ends will be the single-phase current output. We now have the connections, and here is the alternating current output. Let's check the voltage our alternator can generate at a rotation speed of 1,600 RPM. We will check the voltage by setting the selector of our multimeter to AC voltmeter. We place the two clamps on the current output terminals. We will place this Allen head bolt on the alternator shaft so we can make it rotate at 1,600 RPM with this battery drill. It delivers a voltage of 255 volts alternating current. Perfect. We remove the voltmeter and for a second test, connect this lamp to see how well it lights up. Wonderful, it works as expected. We began cutting iron profiles to make the frame of our Liberty Engine 5.0. We will cut 4 profiles at 45-degree angles to create a rectangular structure and welded them together. We cut 4 pieces of iron that will serve to secure the engine and alternator, and another profile to give rigidity to the frame. We drill holes in these pieces to secure the engine and slots to fit the alternator. These 4 profiles will be the legs, but first we welded some pieces with threaded holes to attach rubber feet to prevent vibrations. This job requires an experienced welder to prevent deformation due to heat. The frame is now complete. This is the electric motor we set aside at the beginning. The first thing we will do is connect a 70 microfarad capacitor to convert this 3-phase motor into a single-phase motor. We will also connect this power cable. Notice how the 3 copper plates of the motor are connected. With this delta connection, the motor will operate at 220 volts. Thanks to the capacitor between 2 phases and the single-phase current between those phases, the capacitor simulates the 3rd phase, converting the 3-phase motor to single-phase. We tested it and it works perfectly. To attach the capacitor, we drill some holes in the motor fins. Now we'll prepare the power outlets. We mark all the holes to attach the elements to the structure. Remember to subscribe and leave us a like. This helps us a lot. We thread all the holes to metric 4. This is the box we'll use to make all the electrical connections. We'll drill 3 holes to install cable glands. We screw 4 rubber feet into these holes. We are going to fix the junction box and put the cable glands in place. The cable glands secure and seal the electrical cable entry. We continue securing the 2 sockets. And now we strip the ends to reveal the wires inside. We'll join the wires of the same color. To do this, we use electrical ferrules. Now we insert another cable into the box, which will later connect to the alternator output. Using a terminal block, we finish connecting all the cables of the same color. Now we place the special alternator on the frame, and we secure it with 4 bolts and 4 nuts without tightening them completely. This way we can adjust it later. On the other side, we place the 3-phase electric motor, which we modified to operate as a single-phase motor. We tighten the bolts firmly. We'll connect the capacitor and power outlet cables. We also connect the ground wire. We've connected the capacitor to these 2 terminals. And between these 2 terminals, we've connected the power outlet. We close the motor's electrical box. And connect the power cable to one of the outlets. And finally, we connect the alternator output to this cable, which we previously connected in the electrical box. All the electrical connections are now complete. We close the box to prevent electric shocks while handling the generator. Here are the two pulleys. Each pulley has an inertia disc of 8 kilograms. This will keep the movement more stable. We connect both pulleys using a PJ600 type drive belt. We move the alternator to tension the drive belt. And we tighten the 4 bolts firmly. Now we place this Allen head bolt on the alternator shaft, and our Liberty engine is now ready to begin testing. Let's perform a complete functional test of the Liberty 5.0. First, we activate the 2 power outlets. And now, with this cordless drill, we start the alternator moving. At any moment, you can see the 2 shots without cuts or editing. The system remains very stable. Now with the voltmeter, we measure the voltage generated by our alternator rotating at 1400 RPM. We take the measurement between the blue and brown wires. We have a voltage of approximately 225 volts. This is amazing. We're always fascinated by the energy amplification capabilities of Argalium Alfa. Unfortunately, the creators of this technology prevent its awareness and commercialization. Don't think that this generator will stop after a few minutes. Let's plug in this lamp to increase power consumption. You'll see that the generator remains stable. This would be a good time to give a thumbs up and leave a comment. We read them all. We're also now going to plug in this 800-watt angle grinder. We must be careful not to catch the machine on the cable. We can work with the grinder without any problems. If you want us to make another video with a more in-depth power test, leave it in the comments. How does the Liberty Engine 5.0 work? Through an initial movement on the alternator shaft, it begins to generate power. Holy crap, my hand. We left the blades exposed so you could see there are no hidden batteries. Well, as we said, with the battery drill, we rotate the alternator shaft at 1400 RPM. At that speed, our alternator generates 225 volts, which are injected into both sockets. The engine, in turn, draws power from one of the power outlets. Therefore, it immediately starts up and, through the drive belt, forces the alternator to continue spinning. And so the alternator continues injecting current into the power outlets, closing the loop. This is called an electromechanical feedback system. And thanks to the high energy efficiency of 666% of our modified alternator, this system can remain in operation indefinitely. We filmed the generator from several angles so you can see there are no hidden wires anywhere. This electric generator is very similar to our Liberty Engine 1.0. You can watch the video on our channel. To stop the machine, simply cut off the current to the motor. We do this by turning off this switch. When the alternator speed drops, we can see the light on the other switch go out. And the Liberty engine stops. Remember, our prototypes are not for sale. Beware of scammers. Share this video and join the energy revolution.